November 12, 1944, 9:15 at Bardufoss Airfield in northern Norway. In the operations room, a staff officer from the German fighter wing Jagdgeschwader 5 takes a call on a bad line from the duty officer aboard Tirpitz, anchored off Hokoya, outside Tromsø. The voice stays calm, but it comes fast. The ship's radar has picked up a large formation of heavy bombers coming from the south, high and in numbers, and the identification is already clear. Lancasters, RAF heavy bombers. That mattered at once. A distant radar contact had become a ground order because the bombers were only minutes from the fjord. There was no cushion left. The officer had done this work for 2 years and had launched fighters from fields like Bardufoss more than 100 times. He set the receiver down, checked the clock above the map, and sent the scramble order out at 9:18. On the dispersal pads, engines barked in the cold, and the delay had already begun before any fighter left the ground. Focke-Wulf 190s and Messerschmitt 109s stood ready, 38 aircraft in all. Most of their pilots were young, with little experience, and only recently brought back from Kirkenes. By the clock, they still had a chance. If they climbed fast enough, they could meet the bombers over the fjord. But the first fighter did not lift off until 9:32, 14 minutes after the scramble order. That gap decided it. The staff officer watched the runway, checked the time again, and finished the arithmetic before the next report arrived. At 9:41, the board showed the bombers already over the fjord. At 9:52, the duty officer in Tromsø came back on the line with the same reality. 38 fighters had started too late. The voice has changed. It says Tirpitz, Germany's largest warship, 52,600 tons of welded steel and armor plate, has rolled over in shallow water. The ship is lost. Most of her crew went with her. How? The staff officer asks. How was that possible? No one answers. A pause hangs on the line. That silence matters. This is one bomb. It weighed 12,000 pounds. And before it ever fell, it had been falling for 4 years. That single strike also points backward to the name the battleship carried. Alfred von Tirpitz was the Grand Admiral of the Imperial German Navy, and until his death in 1930, he pushed a fleet meant to challenge the Royal Navy for the oceans. That fleet never broke out. For most of the First World War, it stayed bottled up near its piers. It fought once at Jutland in 1916. One battle changed little. Then the fleet sat at anchor again. After the armistice, surviving German crews scuttled their own ships at Scapa Flow rather than hand them to Britain. That record stayed on paper. Officers of the 1930s grew up reading the post-mortem of von Tirpitz's fleet, and they knew the British line had more range, hit harder, and stayed in the fight longer. They wanted the next German battleship to avoid the same end, and the Bismarck class was their answer. That promise reached the slipway in April 1939. The class had only 2 ships, Bismarck and Tirpitz, and Adolf Hitler came in person for the launch. Alfred von Tirpitz's daughter broke the champagne on the bow, and the hull started its heavy run into the water. The parade hid the real point. 52,600 tons fully loaded, 251 meters long, with 8 38-centimeter guns in 4 twin turrets named Anton, Bruno, Caesar, and Dora. But the figure that mattered later sat in the armor, 40% of the ship's mass, with a main belt up to 320 millimeters. That weight mattered because the armor sat in specific places. Some deck sections carried up to 120 millimeters, and turret faces rose to 360 millimeters of hardened steel. The layout was deliberate. Designers expected shell fire, expected torpedoes, and measured both against Royal Navy guns around 381 and 406 millimeters. They built the ship from older lessons. At Jutland, Britain lost 3 battlecruisers in less than an hour, and German naval architects did not forget why. They wanted a hull that could absorb the weapons fleets already trusted, not just survive a single hit. Against the known threats of its time, that scheme gave Tirpitz very high survivability. An artillery duel or a torpedo attack alone gave Britain no fast way to put her out of action. The pressure stayed on the ship. In 1943, Karl Dönitz made the call. He had replaced Erich Raeder at the top of the German Navy. He came from the U-boat arm, and he never trusted surface ships. Still, he kept Tirpitz commissioned. Fuel was short. Main engines were failing. Yet he held her in a Norwegian fjord, a floating battery at anchor, a hull that mattered more for presence than for speed. In his September 1944 memorandum, he wrote that keeping her in commission would tie down enemy forces and confuse their intentions. By autumn 1944, that was the point, by her presence. Tirpitz was winning by existing. That calculation had already shown its price in June 1942, when Allied Arctic convoy PQ-17 sailed for Arkhangelsk and Murmansk. British commanders ordered it to scatter on a false alarm that Tirpitz was putting to sea. She never left harbor. The convoy still came apart in the Barents Sea. Of 35 merchant ships, only 11 reached the Soviet ports, and 24 were lost. With them went 3,350 vehicles, 210 aircraft, 430 tanks, and more than 99,000 tons of military cargo. Churchill called PQ-17 one of the most melancholy naval episodes of the war. Months earlier, in January 1942, he had told his chiefs of staff to destroy Tirpitz, or at least cripple her, because no other naval target mattered more. That order had a target. The Germans had their own answer, their great ship. A fleet at rest could still deter, their fjord. They built that belief from 30 years of naval war, and Tirpitz in Kifjord matched the idea. Their armor. The assessment was rational when the evidence stopped in 1940. The gap was 4 years wide. It was not mad, it was 4 years stale. They were judging the Royal Navy of 1940, while the Royal Air Force of 1944 was already building something with no precedent in naval history. That gap in German thinking had a physical shape. In 1940, British air crews already knew an ordinary bomb could scorch Tirpitz's deck and still leave the ship alive. The Royal Air Force kept running into the same barrier. A standard Hayek-Stuhl bomb hit the deck, burst on contact, and gave flame, shock, and a hole that looked serious from above. But the damage stayed shallow. The armor below the upper deck remained intact, and the hull, where a battleship lost its life, stayed protected. Brooklands in Surrey mattered here. Before the war, it had already become one of Britain's main aviation centers, so the problem was not noise, it was depth. To break a battleship from the air, a bomb had to pass through one deck, then the next, then another, and burst far lower near the hull below the waterline. Anything that exploded too early wasted most of its force on the ship's skin. Smoke rose, steel held. Barnes Neville Wallace proposed the answer. He was a civilian engineer at Vickers Armstrongs in Brooklands, not a naval officer and not a bomber commander. Later, he would also design Grand Slam, the heaviest British bomb of the war. In 1941, he put his idea into a paper for the Air Ministry. The title was dry and careful, a note on a method of attacking the Axis powers. Wallace argued for striking from underneath, not merely from above. His earthquake principle aimed to drive a very large bomb deep into ground or water beside the target, then let the blast travel through earth, water, and steel. That was the real shift. Not a bigger flash on deck, but a shock delivered where armor gave least protection. The paper reached the Air Ministry in 1941, and officials met it without enthusiasm. 2 years later, proof arrived over the Ruhr. In May 1943, 617 Squadron used Wallace's bouncing bomb to break 2 dams. The raid made his name known across Britain. More important, officials answered his calls. Tallboy followed. It weighed about 5.4 tons and measured about 6.4 meters. Its casing came from a single casting of hardened, high-tensile steel with a nose thicker than 10 centimeters. Inside sat about 2.4 tons of Tirpitz, mixed with aluminum powder to stretch the blast. Dropped from about 5.5 kilometers, Tallboy fell for 37 seconds and closed on the speed of sound. After the dam raid, 617 became Britain's unit for precision strikes on fortified targets, and the Lancaster carried Tallboy most often. The bomb could punch through about 4.9 meters of reinforced concrete. It could also pass an armored battleship deck. By autumn of 1944, Britain finally had a bomb built for armor, yet the German calculations still held in the fjord. It had already held for years. In September 1943, 6 X-craft entered Fjord during Operation Source, and Donald Cameron with Basil Place set charges under the hull before capture. Both men received the Victoria Cross, and their blasts crippled the ship for 6 months, but not for good. In April, Operation Tungsten sent 40 Barracuda dive bombers from Royal Navy carriers, and they scored about 15 direct hits. The main deck armor held. Summer brought Mascot and then Goodwood, and each raid met the same armor without turning damage into a sinking. By September, Operation Paravane, flown from a staging field in northern Russia, had torn up the bow badly enough to take away full speed. Still afloat. One layer fell at a time, but no raid yet joined penetration, accuracy, and clear weather in the same moment. That was the pattern. On October 29th, clouds rolled across the fjord at the last moment, and Operation Obviate lost the target again. Britain had already spent its best answers, and by November 12, 1944, Tirpitz was still afloat. Operation Catechism began before dawn. 32 Tallboys hung under 32 modified Lancasters, lifting from 3 Scottish airfields in darkness toward a fjord in northern Norway. The trade was blunt. To buy the distance, crews removed the mid-upper turrets, the nose turrets, and armor plate, then added extra fuel tanks. The bombers went beyond friendly fighter range in aircraft that had traded guns for petrol. No escort came. After years of failed attacks, crew risk had become part of the plan. In July, James Bryan Tate had taken command of 617 Squadron from Leonard Cheshire. He was 27 and had flown 101 operational missions. He already held the Distinguished Service Order with 3 bars and the Distinguished Flying Cross with bar. Now Tate led the column to the fjord. That approach set the next failure in motion. In his cockpit, Tate remembered the sun on the horizon and pink light across the snow-covered mountains. The bombers came from the southeast at high altitude, stretched into a long, staggered stream on a course the defenses had not expected. Tirpitz saw them and sent a warning to the fighter field at Bardufoss at 9:15. It changed little. At 9:38, the battleship opened fire with 8 38-centimeter guns from more than 21 kilometers away, but the shells passed above and behind the formation. Shore anti-aircraft batteries fired next. Too late. The warning had arrived. The defense had not caught up. By the time the gunners found the range, Tate was already on the first run. He dropped first, and the first Tallboy hit. It was a 5-ton deep penetration bomb built to punch through armor before it burst. A second struck moments later amidships, between the funnel and the aircraft catapult, and drove through the armored hull. Then a third fell off the port side, bored down through the water, and detonated against the harbor floor under the ship. That geometry mattered. There was no turn. Tirpitz lay at anchor in shallow water, with engines barely working, so she could fire upward and cover herself, but she could not maneuver or spoil the aim point. William Lee, the Australian bomb aimer in a trailing Lancaster, wrote that their bomb went straight into the center of the smoke. After the first hits, fire from the ship stopped. That silence came at a price inside the Lancasters. The crews of 617 Squadron and 9 Squadron flew this raid in stripped, unarmored aircraft. and they pulled off their own turrets to free space for fuel and one bomb. They went north without escort, into the Arctic light, with less protection than their aircraft once carried. Their names should be kept. Back to the fjord. In this raid, 617 and 9 went out in stripped Lancasters for fuel and a single bomb. That risk bought the hit. It did not explain the weapon. Germany had the steel, the chemical industry, and the machining skill, and in the early war years, parts of its aircraft industry outpaced Britain. Even so, Germany never built a Tallboy. The gap was not raw material. It was the designer. Barnes-Wallis did not wear a uniform, and no senior patron carried him through the first years. He worked in Surrey for a private engineering firm. He was also a Quaker. That mattered. Wallis treated weapons as a moral problem, not a career badge, and he argued that a more efficient bomb could shorten war and spare lives. Cold steel and fine tolerances were only the start. Someone still had to turn them into a casing, a theory, and a target. Germany had the ingredients. Britain had the man. Barnes-Wallis was a private engineer from Surrey with no military rank. That only mattered if his idea survived its first pass through London. Rank did not decide it. Britain's defense establishment was no meritocracy, and that weakness gave Wallis one narrow opening. The Air Ministry's senior men were former pilots, not engineers. They knew aircraft in the air, less on paper. The Ministry for Aircraft Production answered to a newspaper baron, and RAF command often felt like a gentleman's club. Strange ideas could still stay in the room. So when Wallis circulated his earthquake bomb paper in 1941, most officials did not take it seriously. They did not throw it away. In that culture, a persistent outsider could outlast habit, rank, and official doubt long enough for another reading. He only had to stay interesting and be right. The 1941 paper on earthquake bombs was not rejected. Records show that Air Chief Marshal Sir Wilfrid Freeman read the paper and quietly kept it alive. He understood engineering. He never took the project on as his own, but he kept it from dying in a file, and that was enough. Tallboy then reached production in small batches, almost by hand. Each casing was cast as one piece of high-tensile steel. Each bomb was finished and fused on its own. It cost more than any other conventional weapon in the British arsenal. While Bomber Command dropped more than 600,000 tons on Germany, only 854 Tallboys ever went into combat. That tiny stock changed the rule in the air. If crews missed the target window, they brought the bomb back to base, not into the sea. The Royal Air Force treated Tallboys as irreplaceable because each bomb was finished by hand and only 854 reached combat. The most valuable target was Tirpitz. Churchill called the battleship a beast. One handmade British bomb struck a ship displacing 52,600 tons, and the weapon that did it weighed about 5.4 tons. About 5.4 tons against 52,600 tons of Tirpitz. That mismatch in weight pointed to a larger mismatch on the ground. Behind one bomb stood a British circle Germany in 1944 could no longer match. Tallboy took 3 years to win support, and the Royal Air Force did not want it at first. Steel was not the problem, and explosive chemistry was not the problem either. The real limit sat inside the German war economy. By 1944, it had no room for a private Quaker engineer to chase an unwanted idea for 3 years. Britain still had that room. So Tallboy did not come from one firm. It linked air planners, laboratories, design offices, and factories. The Royal Air Force backed it, universities tested it, engineering institutes refined it, and private firms carried it into production. Vickers, Avro, and Rolls-Royce all sat inside that circle. The same amateur engineering tradition had already produced radar, code-breaking, bouncing bombs, and Spitfires. Germany still had metal and chemistry. It no longer had that circle. All of that work closed around one weapon of about 5.4 tons. That investment left marks in steel. After the war, British teams from the Royal Air Force and the Royal Navy followed those marks across Tirpitz's hull. They checked the entry holes, measured the torn metal and the spread of the damage, and matched the scars to bomb types. The language stayed cold. Their conclusion was careful and technical. No single cause sank the ship. They listed Tallboy hits and the near miss that made the seabed beneath her. Then came open watertight doors, stability limits, the failed smokescreen, and failed fighter cover. Every point belonged on the page, yet none of it explained where that attack had really come from. Behind those holes stood 4 years of Royal Air Force work and 854 bombs, enough to produce a weapon German naval staff had not expected. The long technical report ended with that admission. They had not found one single cause of the ship's loss. That lack of a single cause did not stop the hunt for a single culprit. At 9:52 on the morning of November 12, 1944, Tirpitz had already rolled over, and German command in Norway started shaping its answer within hours. They did not open with the wreck itself, they opened with a court-martial. The first man under it was Major Heinrich Erler, commander of the fighter cover. He was an experienced Luftwaffe pilot with more than 100 confirmed victories on the Eastern Front, and he was temporarily leading Jagdgeschwader 5 at Bardufoss, the only nearby fighter group with any real chance against a daylight bomber raid. That record mattered. So did his post. But the delay began before any courtroom. Erler was away from his operations room that morning, and a junior officer held the post when short radio warnings came in from the ship. The warning arrived at 9:15. From there, headquarters tightened its case around one officer. The scramble order went out at 9:18, and the first fighters only began to take off at 9:32. That delay put Major Heinrich Erler in the dock. He was an Eastern Front ace with more than 100 victories, yet headquarters narrowed the case to one man. The court-martial gave him 3 years. Then the sentence was reduced. He was demoted and sent back to flying duty. 5 months after the Tirpitz raid, on April 4, 1945, he was killed in action. Many surviving comrades said headquarters had made him the scapegoat. They pointed to 3 failures: the warning chain, fuel supply, and pilot training. The failure reached far beyond his office. They also said an instant scramble would have changed little because the Royal Air Force chose its approach and timing to leave the fighters only minutes. That mattered. Too late anyway. The bombs began to fall 9 minutes later, and the intercept window was already gone. With the intercept window gone, the fight moved to the hull. Norwegian welders were already cutting into Tirpitz's overturned side. Captain Robert Weber had taken command only 8 days earlier. He expected about 3 more weeks before polar darkness hid the ship from air attack until spring. At 9:50, the magazine under Caesar turret blew. 2 minutes later, Tirpitz capsized. Weber died in the armored command post with almost all his officers. Roughly 1,700 men were aboard that morning. The death toll never settled, somewhere between 950 and 1,200. In the first 2 hours, rescuers pulled out 596. Over the next 36 hours, Norwegian welders used torches the garrison had not known they possessed and cut 82 more men out alive. Once the cutting stopped, the Admiralty wanted paper. After 596 men came out and Norwegian welders cut 82 more free, Donat sent a commission of senior naval officers to Tromsø and demanded a written conclusion. They questioned survivors. They inspected the wreck. Then they reduced the loss to a sentence. That sentence put the blame under the hull. The commission wrote that the actual depth of the prepared berth did not conform to the requirements and directions of the commander-in-chief. In other words, the standing place was wrong. The official cause became the seabed. The report also mentioned an uneven sandbank meant to support the ship and check a capsize. Just one line. A Tallboy near miss on the 29th of October tore up that bank during Operation Obviate 2 weeks before the sinking. The commission recorded that damage, then moved past it and returned to the berth. That choice left little room on paper for the bomb's real effect, or for the decisions that kept Tirpitz dependent on that ground. In the official record, the loss remained a formula about the inadequate depth of a prepared berth. That wording did not settle the strike itself. In British files beside the wreck stands a little-known name, Douglas Tweddle. He was the bomb aimer of 9 Squadron, flying that morning in Lancaster LM-220. The records of his squadron credit his Tallboy with the killer blow against Tirpitz, but the claim never closed. Wing Commander Tate's citation in the London Gazette gives Tate's bomb as the first hit. Since the day of the raid, 9 Squadron and 617th Squadron have argued over that line. Smoke over the fjord hid the exact path of the bombs. That detail matters because the ship fell to only a few hits. Tweddle is barely known. Tate is not. The likelier answer is that more than one Tallboy struck, and no single airman can carry the whole result alone. Still, one Tallboy weighing about 5.5 tons hit Tirpitz that morning, and the name tied to that strike stayed in the after-action reports of the 2 squadrons. While British crews argued over credit, Berlin had already chosen its wording for the same loss. It would issue 3 official answers. The first came from Joseph Goebbels' propaganda ministry, and the communiqué went out the day after the raid. It said Tirpitz was out of action in shallow water off Norway, and that most of the crew had been saved. That line was false when it was broadcast, because as many as 1,200 sailors were already dead. It also pushed the British bomb and the scale of the loss out of the sentence. Then the Navy answered, as Karl Dönitz ordered an inquiry and the board blamed the berth's shallow depth. On paper, Goebbels had shallow water. The Navy had a shallow berth. After the propaganda note and the naval inquiry, one trail still matters: Hitler's own record. It is not in the surviving situation conference minutes. It is not in the German High Command war diary or in Goebbels' diaries. Post-war interrogations do not preserve it. Speer's memoirs do not preserve it. Neither do the Dönitz papers or the Raeder papers. It is nowhere. The most powerful man in Germany left no recorded word. In 1939, Hitler attended Tirpitz's launch in person and had already approved the Bismarck class as the core of the German surface fleet. He had received briefings on the ship for years. Then, one British bomb ended it. Recorded words from Hitler on Tirpitz's loss? 0. Berlin answered with less than a sentence. The propaganda ministry lied, and the Navy pointed to the harbor floor. The head of state said nothing. The public story in Berlin stopped there. London did the opposite. On November 14th, Wing Commander Tate faced the press, and photographers caught him smiling. Royal Air Force film of the raid reached cinemas around the world within days, fixing the result for a mass audience. Churchill congratulated the squadrons, and Roosevelt and Stalin congratulated him. At the top of Berlin, the answer to Tirpitz's destruction was silence. Behind that silence sat a technical answer that British planners had been chasing for 4 years. One answer held. On the morning of November 12th, it finally broke open. Tirpitz was weakest on the upper deck. The blow came from above. This was not a contest of courage or professionalism, not talent alone. The Luftwaffe pilots at Bardufoss were brave and professional, and the German naval staff came from a strong engineering tradition. They had built a ship that survived years of Allied attacks. It started with one paper. 4 years earlier, Barnes Wallis, a Quaker engineer at a private firm in Surrey, had written it. He came from aircraft work and heavy bomb design, so the idea grew out of practice. British officials then let him build the bomb he described. That bomb reached the one place where the battleship could be hurt. Then the clock took over at Bardufoss. In northern Norway, the interception window was short, and the papers record each minute. The officer at the base is a composite face, built from several Luftwaffe staff officers. His lines are invented. The timings are not. The warning call came at 9:15. The scramble order followed at 9:18. But the runway cleared too slowly, and the first fighter left ground only at 9:32. Major Heinrich Erler was real. Captain Robert Weiber was real. At 9:52, Tirpitz capsized. Once those minutes were over, 3 names remained: Douglas Tweddle, Barnes Wallace, and James Bryan Tate. Tweddle flew, Wallace designed, and Tate led the squadron, while Royal Air Force sortie logs fixed crew, time, and target on paper. Tallboy weighed about 5.5 tons. Wallace spent 4 years on it, and crews dropped 854. Tirpitz was the largest target that bomb destroyed, and not its last one. Tate's squadron logs and his citation are still public documents,